a 21.3 using special factors to solve equations. So really, this is just a repeat of the previous lesson. The only difference is these are special cases. So when we start talking about them, the first one we want to talk about here is our perfect square trinomial. So the book here uses the algebra tiles and goes through a demonstration and all that. I'm going to skip immediately to looking at an example. Now, right before I do that, I do want to point out this box. This is a really good indicator of how the perfect square trinomial works. You can look at the example, you can look at the rules over here on the left hand side. They're very good explanations. So if you had to reference, this is where I would go to reference them. So they give you an example down at the bottom again, worked out without the algebra tiles, just using the format. Another one here that you can fill in the blank. And I'm going to do the year turn problems right here. So the first thing we have to do is recognize if it is a perfect square trinomial. So how do we do that? Well, the first thing you have to do anytime you factor is always look again for that GCF. So in this case, all of these have a y and they're all divisible by 2. So the GCF here would be 2y. Now if I take that GCF out, that leaves a y squared plus 6y, because 2 times 6 is 12, plus 9. Now, what makes this a perfect square trinomial? A couple of things. First, the first term and the third term both have to be squares. Again, that always has to be a positive, because when you square two negatives, you get a positive. The other thing is this middle term has to be double the product of the two square root factors. Okay, so what's that mean? So I have 2y. What do you square to get y squared when you square y? What do you square to get a positive 9? Well, you could square a negative 3 or a positive 3. How do I know which one to do? You always look at your middle term for your sign. So in this case, it's a plus. Therefore, this would be a positive 3. Now, remember, you have to get that middle term. How do you get that? You multiply the two factors here and then double it. So y times 3 would be 3y, doubled would give you 6y. So that's how you know that's a perfect square trinomial. And then this is the factored form. Now, why understand a perfect square trinomial? Well, in this case, you actually have this added factor here, which is why you have 3 roots, because it's to the third power. However, if you were to eliminate this factor and just look at this one, it would have 2 roots. It would be at negative 3, but you can only graph it once. So the vertex is at negative 3. That is your x-intercept. It's what, again, we refer to as a double root that we've kind of talked about in class and referred to in the previous lessons. So in completely factored form, this is what we ended up with. So let's go to the next problem over here. Again, look for a GCF. Well, in this case, there is no GCF here, especially since this is a 1. Only thing that goes into that's 1. So ask yourself, is this a square? Yes. What do you square to get 100z squared? 10z. Is this a square? Yes. What do you square to get a positive 1? 1. Now, is it positive or negative? Look back up here at your middle term. That's a minus. Therefore, this must be a minus. Now, double check what has to happen. When you multiply these, you get 10z, multiply that by 2, and you get 20z, which is what you have up here. So yes, this is a perfect squared trinomial, and there you go. So the other special case is a difference of squares. So difference of squares is pretty easy in that it is used by the name itself. I mean, the example they give here, that's a square, that's a square, this is the difference, subtraction. So again, you can look at the examples they give you here. You could do the fill in the blank. I'm going to go immediately to the your turn problems. So the first one. Ask yourself first if the first term is a square. And the answer is yes. Is the second term a square? Yes, and this is where you have to know your multiplication of square terms. How do you get 144? You square 12. Because it is difference, we're missing that middle term. Because when you multiply, take a quadratic in standard form and factor it, you should have two binomials. And that's what we get here. We get x plus 12 and x minus 12. This is just missing that middle term in the standard form. And the reason it's missing is because one case is a positive, one case is a negative, and they cancel out. So in our next example, you look again, are they squares? And the answer is yes. Now, be careful here. This is a square even though it's to the fourth power. Why? Because what do you multiply times itself to get y to the fourth would be y squared times y squared. However, in this particular case, what we're going to do is what we always want to do first. Look for a GCF. Well, what'll go into both of these, 81 and 9? 9 will. We have y to the fourth, y to the second. So how many y's can I take out? I can take out 2 y's. What's that leave? Well, 9 times 9 would give me 81. And then I took 2 of the y's out, so that leaves 2 y's in this first term here. Minus, I took the 9 out right here. I took the y squared out right here. So you might be thinking, well, that leaves nothing here. But actuality, remember, this is distributive property. What do I have to multiply here to get what I had up here? Well, that has to be a 1. So it's not nothing. It's factored. You've taken a factor out. So it still has to multiply times something inside the binomial. Well, now I have a difference of squares here. So what do I do with my GCF? I just bring it down. I have 2 factors. Remember, one is a plus, one's a minus. What do I square to get 9? 3. I have y squared, so that'd be y times y. What do I square to get 1? It'd be 1 and 1. So the only other thing here in this lesson is how to solve and use this whole idea of factoring special cases to solve. So again, we're going to go straight to the your turn. Remember, if you are ever going to solve by factoring, it must always be set equal to 0, the equation. So this is a perfect square trinomial. How do I know that? That's a square. What do I multiply to get that? 5x times 5x. 1 is a square. Remember, this is a positive. So when I square to get 1, 1. Now, how do I determine my sign in the middle? I'll look back up here. That's a minus, so this is a minus. And that is squared. Now, double check. 5x times 1 is 5x. Multiply that by 2, and you can almost think of the square being a 2. So 5x times 1 is 5x times 2 would be 10x. So that one is factored. Now, that's not the solution. He wants us to solve. How do we solve? Well, really, this is 5x minus 1 times 5x minus 1 equals 0. So how would I solve? I said each factor equal to 0, or we've talked about the shortcut. What do? You take the opposite of negative 1, which is positive, and then you divide by 5. So x would equal 1/5. Well, what's this one going to be? This would also be x equals 1/5, and again, that is referred to as a double root. It's the same answer used 2 different times. It's also why when you graph it on the calculator, if you were to graph the parabola at 1/5, you're going to have the vertex. So the vertex is actually going to be where the root is. That's why there's only one point, a solution, even though it's a quadratic function to the second degree. It should have 2 solutions. Just graphically, you can only put it at the point one time because that's the only way you can graph 1/5. Alright, so we go to the next example. Again, look for GCF. I can take out a 2x squared. 2 times 4 gives me 8. Took 2 of the x's out, that leaves 2 x's. 2 times 1 is 2, and then the x squared times 1 gives me the x squared. But then I can factor this. This is now difference of squares. So I have my GCF just comes down, 2x squared. My difference of squares, remember one case is positive, one case is negative. What do you square to get 4? 2. What do you multiply to get x squared? X and x. And what do you square to get 1? 1 and 1. So what are my roots? So what would make that 0 if x is 0? What would make that 0 if x is, remember, take the opposite of +1 is -1, and then divide by 2. And then what would this one be? X would be a positive 1/2. And that should always happen with difference of squares. One will be a positive answer, one's a negative. Why? Because your factors are one's a plus, one's a minus. So this one again has 3 roots. But if you go back up here, it's to the 4th degree. So I thought we said, okay, if the power's 4, it should have 4 answers. Well, again, 0 is referred to as a double root because it's the same answer used 2 different times. You have 2x times x. So it would be 0 used twice. So then the only other thing here is, how does this problem? So again, I'm going to your turn, and I'm just going to do this first one, number 10. A volleyball player sets the ball in the air, and the height of the ball after t seconds is given in feet by the given equation. A teammate wants to... Now, let's review the equation before I go on. This is the equation we learned earlier in a lesson, which talked about height is equal to negative 16t squared plus vt, where v was the initial velocity, plus s, where s was the initial height. This is a formula you'll use if you take physics. You'll use this one. There is another one where it's not in feet and seconds, but in meters. So the coefficient here changes to a negative 4.9. Because we're talking about flight of something in the air, this is the position due to gravity. It's got to be downward, because gravity forces it down. So you shoot something up or throw something up, and then eventually it has to come down, which is why in the formula, if you look, our A here is a negative because it's got to open downward. So just trying to tie together all the things that we've learned, but how it applies specifically to a scientific formula. So anyway, let's continue. So we have the formula. A teammate wants to wait until the ball is 8 feet in the air before she spikes it. When should the teammate spike the ball? So we're looking for a time here. How many reasonable solutions are to this problem? Explain. So in this case, we're not setting it equal to 0. We're wanting to set it equal to 8. That's what we want our height to be. So 8 equals negative 16t squared plus 12t plus 6. So we've looked before how you could graph this and graph the 2 separate functions here and set them equal, or graph them on the graphing calculator and find where they intersect. But instead, what I'm going to do is I'm just going to get it all equal to 0. Now in this case, I'm going to move this over. And the only reason I'm moving these terms over to the other side rather than the 8 is because I want my first term to be positive. So 16t squared. Move the 12t over, it becomes negative. Move the 6 over, subtract 6 from 8, and that becomes plus 2. Now that all equals 0. So now what I need to do, now I need to factor. First thing I'm going to do again, 2 will go into all that. So I take out my GCF. That leaves 8t squared, because 2 times 8 is 16, minus 6. 2 times 6 is 12, plus 1 equals 0. Now I need to try to find the solution. Okay. So I try to look and see, was this a special case? But it's actually not a special case. This is not a perfect square trinomial because 8 is not a perfect square. nor is it a difference of squares. So how would I solve this one? Well, in this case, you would actually have to go through and either factor or try to do it on the calculator. In this case, I'm going to factor. So what I'm going to do is one of the methods we did earlier, and I'm going to try to do the Punnett square. And what I know, how do I get 1? Well, that's 1 times 1. And that gives me a positive 1. Now, should it be minus or should it be plus? Well, in this case, I know it should be a minus. How do I know they should be negative 1? Because my middle term's negative. So then I need to figure out what will give me 8t squared. So you could go back and do 8 times 1 is 8, and I need factors of 8 that give me 6, which are 2 and 4. Now they both have to be negative, so this has to be negative 2t, this has to be negative 4t. Oops. So what does that mean I would have to have here? That would have to be 4t in order to get 4t times negative 1 to give me that negative 4t. What goes up here? This would have to be 2t. Why? Because 2t times negative 1 would give me the negative 2t here. And what happens when I multiply those two terms? I get the 8t squared. So here I have my two factors. So I have 4t minus 1 and 2t minus 1. So what's my time here? Time would be 1/4. And the time here would be 1/2. Okay. Now I have two answers. So let's go back up here. How many reasonable solutions are to this problem? Well, being a volleyball coach, I know that the reason there are 2 times, but also both answers are reasonable, and here's why. If the setter sets the ball, it's going to go up, and then it's going to come back down. When it goes up, the time is 1/4. When it comes back down, it is 1/2 second. Now, just because I coach volleyball, I know if you hit it here, that's referred to as a quick hit. It's when the ball's actually going up. Most people would refer to the answer being here after the ball has come at its peak and is coming back down, and then the hitter hits the ball. But in this case, either one or both would be reasonable answers. The other thing you need to put are your units, which are seconds. So, for this particular lesson, you are doing, on page 1018, numbers 1 through 25 odd.